Hello everyone. In this video I'm going to walk through how to use the BA2 Plus calculator to work time value of money problems. And for this video I've chosen 11 different problems to work through. So the calculator I'm going to use is the BA2 Plus Professional. You don't need to have the Professional. I use it in this case because of the angle of the screen. It looks straight up, and so it allows me to show things a little bit better. There's two additional functions on the Professional version of this calculator that's not on the regular version, but we won't be using those. Everything else between the regular BA2 Plus and the Professional is the same. All right. So we're going to go through some time value of money problems, or TVM problems. And the first one here has to do with the present value or future value of a lump sum. So the problem says, if your discount rate is 7.5% and you are given the choice between $2,500 today or $4,000 7 years from now, which would you choose? So hopefully you choose the one that has the highest value today. So what we're going to do here is I'm going to work this in two different ways. I'm going to work it as the present value problem that I just described. I'm also going to work it as a future value problem. So if we took the $2,500 today and invested it at 7.5%, would we have more than $4,000 7 years from now? So like I said, I'm going to start off with the present value of a lump sum problem. And I apologize, my handwriting isn't the best. I'm used to working on a computer. However, to demonstrate these calculators, I need to handwrite everything out and demonstrate on the calculator rather than over the computer there. So what my inputs are going to look like, my N in this case is equal to the number of years. And so it's going to be 7 years. Now that changes if we have multiple payments per year. My I is going to be equal to 7.5. And in the TI calculators, the interest rate is a whole number rather than as a decimal. My present value is what I'm looking for. My future value is equal to 4,000. And my payment is 0 because this is a lump sum. So I'm trying to find the present value here. So in my calculator, when I start off using it for any kind of time value of money problem, I do two things. I first start off by looking up here, and if this is set for an annuity due, it's going to say BGN up here, but it doesn't, so I'm not going to worry about that. I'll show you that in a later problem. I secondly want to make sure I only have one payment per year. In this case I have two, so I need to set this to 1. Otherwise it's going to think that really the length of time is 3.5 years rather than 7. So I'm going to press second, and IY, oh sorry, already did that. Second IY, just to pull that up again. So above the IY it says P/Y for payments per year. I'm going to select 1 and then enter. And so that makes it 1 payment per year. And now the last thing I'm going to do is clear out all my time value of money variables. So I press second and future value, and above that you can see clear CLR TVM. That's going to clear everything out and make everything along this line equal to 0. So I'm going to put my inputs in now. My N is equal to 7, so I press 7 and then N. My interest rate is 7.5, so I'm going to press IY and 7.5. Oh, so 7.5 and then IY. My future value is 4,000, so I'm going to press 4,000 and future value. And then I'm going to press compute and payment. Oops, and that's absolutely wrong. Put in 0 for my payment and press compute present value. And it's $2,411.02. Because I accidentally pressed the payment button, I had to make that equal to 0 again. To $2,411. Now you might notice that this is a negative in front of that $2,411.02. That's because it's a cash outflow. So later on in some other problems, we're going to see where that's very important, especially when we're calculating any kind of interest rate. You need to have cash outflows and cash inflows for the calculator to know what's going on and how to calculate that return. So the second question here says, well, the second part of this, or the second way to work this, is that we're going to find the future value of a lump sum. So instead of saying we're going to find the present value of the $4,000, this time we're going to find the future value of the $2,500. So my N, again, is equal to 7. My present value is equal to 2,500, because that's what I could get today. My interest rate is equal to 7.5. And now I'm going to solve for my future value. Okay. So the first thing I'm going to do is press second and clear TVM. There's no BGN up here again, so it's not set up for an annuity due, and I've already reset the payments per year to 1, so I'm good there. Now I just need to input my variables. So I've got 7 for N, 2,500 for the present value, and I actually need to make this negative. Otherwise, my future value is going to be a negative value. And then I set my interest rate for 7.5. I'm going to compute my future value, and I get $4,147.62. So in either case, what this is telling me is that it's better to take the $2,500 today if I can get 7.5% on my money. Because if I take the $4,000 in 7 years, if I discount that back, it's worth $24,1102, which is less than what I could take today. Okay. Or if I take that $2,500 today and invest it at my discount rate of 7.5%, I'll have more than $4,000. I'll have $4,147.63 in 7 years. All right. The second question says this: if you put $3,000 into an account paying 4% interest, how long will it take you to double your money? And so I'm gonna discuss something else that goes along with this, but first I'm going to work the problem. So I'm looking for N. My present value is equal to negative 3,000. My future value is going to be double that, because that's what I'm going for. It's going to be 6,000. Again, note, negative number here, positive number here. I'm going to actually work this incorrectly, and so you can see what happens. And my account pays an interest rate of 4%. So just like I said before, I'm going to go through and clear everything out. Again, it's not set up for an annuity due, and it's only set for 1 payment per year, so I'm good on that. So like I said, I'm going to make a mistake here just to show you what it looks like. I'm going to put 3,000, not negative, in for my present value. I'm going to put 6,000 in for my future value. I'm going to put 4 in for my interest rate, and then I'm going to compute N. It's going to give me an error message. So the reason why it's giving me an error message is that I put a positive cash flow in for the present value and a positive cash flow in for the future value. So it can't really calculate how long it would take, because neither of these is an investment. Neither of these is cash flow coming out of my pocket and putting it into an account paying 4% a year. So I'm going to correct this by putting 3,000 negative in for my present value, and then computing N. And I get 17.67 years. Right. So I want to introduce you to, if you've not seen it before, the rule of 72. Divide 72 by the interest rate as a whole number. So in parentheses, I'm going to put here as a whole number, to estimate the time it takes to double your money. Sorry. And we'll see that. I'll show you, I'll demonstrate that right now. And again, this is just an estimate, but it can give you a very quick idea of how long it will take. So I'm going to take my my 72 divided by 4%, or 4. And that's going to tell me it's going to take about 18 years to double my money, which is fairly close to my answer here of 17.67 years. The next question says, if you need to have $10,000 in 4 years and have $7,500 to invest today, what rate of interest will you need to earn on your money? So now, obviously, we're trying to solve for the interest rate. We have our present value, $7,500, our future value, $10,000, and our time is equal to 4 years. So n is equal to 4. Present value is equal to negative 7,500. And the future value is equal to 10,000. Okay. And don't put the commas in your calculator. So I'm solving for my interest rate. So again, what I'm going to do is go to my calculator. And I say this every time just as a reminder. Your payments per year, if you've been going along with this video, is already set to 1. But I'll just show you here. I press second and I/Y just to make sure that that's still set to 1. I'm going to clear out my time value of money variables by pressing second and future value. And now I'm going to input everything here. 4 is equal to n. Negative 7,500 is equal to the present value. 10,000 is equal to the future value. I'm going to calculate my interest rate. Okay. Try that again. 7,500 negative is my present value. 10,000 is my future value. N is equal to 4. And I'm going to compute my interest rate at 7.46%. All right. So the next question says, you are investigating an investment that guarantees a payment of $10,000 40 years from now if you invest $1,000 today, but it requires you to leave the money in for the 40 years. What rate of return does this investment pay? So that's the first question. Again, we're looking for the interest rate. It's a lump sum problem. My present value is equal to 1,000. My future value is equal to 10,000. My N is equal to 40. So I'm going to press second and future value to clear out all my time value of money variables. 1,000 is my present value, negative is my present value. My future value is 10,000. My payment is 0, so I'm not going to put anything there. My time period is 40, so 40 for N. I'm going to compute my interest rate at 5.93%, 925%. So that answers the first part of the problem. The second part of the problem says If the average return on the stock market is 9.5%, which investment do you prefer? So this is really an opinion question. You can get a guaranteed return here of 5.93%, which is pretty darn good for a guaranteed return. However, it requires you to lock your money up for 40 years. You can't take it out early. On the other hand, you could put your money in the stock market. You could take your money out early. You get a higher return, or a higher expected return. The average return's been that, 9.5%, but it might not actually get 9.5% while your money's invested. So there's more risk involved with the returns for the stock market rather than our guaranteed return here. The next question is a tough question. It's a two-parter. It says 18 years from now, you expect to send your child to college. By that time, the tuition is expected to be $20,000 per year. If you expect them to graduate in 4 years and you can earn 8% on your money, how much do you need to invest each year until then to be able to pay for their college? So, so it says part one, how much will you need in the bank in 18 years? Okay, so we're going to assume that you're going to pay $20,000 per year at the beginning of each year. So for this one, I like to draw a timeline just to demonstrate what's going on. We're going to skip a few years in the timeline, but I need to show you here at the end. You're going to have 4 years of $20,000 payments. So for those 4 years, you're going to make a $20,000 payment at the beginning of each year. Assumed tuition is paid in full at the beginning of each year. Okay? So this is an annuity due, this section of it. Because our payments begin at the beginning of the year, it's an annuity due. So I need to find out, this is time 18, this is when I need the money right here. So I need to find out how much I need to invest for these 18 years leading up to that time period. Okay, so that's what I'm going to do first. So I'm going to find the present value of an annuity, and not just a regular annuity, but an annuity due. The present value of an annuity due. So for this one, I need to make a few changes in my calculator. First thing I'm going to do is clear everything out. The next thing I want to do is to change this from a regular annuity to an annuity due. So in order to do that, I'm going to press second and then payment. And you'll notice above payment it says BGN. And it says end here. Okay. So what this means is that when working on annuities in the calculator as it is, the calculator assumes that the payment occurs at the end of each period rather than at the beginning. So I need to change that by pressing second and then enter. So it's got BG in there, that's what I want. And then I'm going to press clear to get out of that. But notice that this says BGN up here. So I can see, without having to go to that screen, I can see this is set up for an annuity due. So I want to find the present value of this $20,000 cash outflow at the beginning of the next 4 years. So my inputs are going to look like this. N is equal to 4. My payment is negative 20,000. So the reason why it's negative 20,000 is because I'm going to be taking $20,000 out of my pocket for every year at the beginning of each of the next 4 years. My interest rate is 8%. This is important because any money still left in my account during this 4-year period. So the first year I'm going to make a payment of $20,000, but all the rest of the money I have in that account is going to earn 8% interest. My future value is 0. At the end of the 4 years, I'm all out of money. So now I need to figure out my present value. So in my calculator, I'm going to put in, for n is 4, so 4n, 20,000 negative is my payment, 8% is my interest, my future value is 0, and now I'm going to calculate my present value, and for that I get $71,541.94. So what that means is at the end of 18 years, I need to have that amount of money in that account in order to make those 4 $20,000 payments. Okay, so that is my present value for here is that amount, but now that's going to be the future value. Okay, it's going to be the future value of my payments here. So now I'm solving for my payment. My present value is equal to 0. I'm starting off with 0 times 0. Okay, that's all I got. And then I'm going to make 18 payments, so my n is equal to 18. I need to figure out what that payment's going to be. My future value is equal to $71,541.94. And I'm solving, my interest rate is equal to 8%. And then I'm going to solve for that payment. So the first thing I need to do is go press second and then my payment button. Because this is going to be a regular annuity, I'm making my payments at the end of the year. So the last question here is we're going to solve for an annuity due if I made my first payment today. But we're going to start off by solving for a regular annuity. So I'm going to press second and enter to switch that back over to end. And you can see that BGN up here went away. I'm going to put in 0 for my present value. My interest rate is 8%. My N is equal to 18. My future value is at $71,541.94. And now I'm going to calculate my payment. Sorry. Okay, and so my payment is going to be $1,910.32 per year. Okay, so for each of the next 18 years, I'm going to make a payment of $1,910.32. And I don't have enough room there to write it out each time. But what that's going to result in is at time 18, I'm going to have this amount of money. Okay? And that's the amount of money I need at that time period. All right. So now to answer this last question, how much if you make the first payment today? So I'm going to say payment is equal to $1,910.32. So if I make the first payment today, I get an extra year's worth of interest. And because of that, I'm still going to only make 18 payments. But my last payment's going to be at time 17 rather than time 18 because my first payment is today at time 0. And so what I'm going to do here is press second and payment and second and enter to make this an annuity due problem. And then re-put in all my inputs here. 0 is my present value. My future value is $71,541.94. So my future value is there. My interest rate is still 8%. My N is 18. And now again I'm going to compute my payment. And it's $1,768.81. So I'm going to put annuity due. So I'm going to put annuity due is equal to the payment, $1,768.81. All right. So you can see here that the annuity due payment is less than the regular annuity payment. Again, because I am getting an extra year's worth of interest. I'm going to flip over here to the next page. So on the next page here, we're going to work on an annuity, but instead of having an annual payment, we're going to have 12 payments per year. And it says here, you are considering buying a 2021 Toyota Corolla. The dealer has offered to sell it to you for $21,000 with payment terms of 60 months and an interest rate of 4%. What will your monthly payment? What will be your monthly payment? So this is a regular annuity problem, but with monthly payments. So my payments per year are going to switch from 1 to 12. My N is going to be equal to 60, so five years. My present value is positive cash flow. I'm going to get $21,000 from that loan today. My future value is 0 because it's going to pay off in those 5 years, so there's not going to be anything left. So my interest rate is going to be 4%. And so I need to solve for the payment. So the first thing I want to do is I'm going to get rid of this BGN because I'm not going to make my first car payment today. I'm going to wait a month because they need to send me the payment booklet and everything. So I'm going to press second and payment and second and enter. And now I want to switch this up for 12 payments per year. So I'm going to press second and I/Y and change that to 12 and then press enter. And so you might notice here I'm pressing enter. It's because in this case, I need to press enter for that equal sign to show up. If that equal sign does not show up, then it's not actually in the calculator. And now I'm going to clear out all my time value of money variables. It doesn't clear out the two things I just did because they're not in this row. Okay? They're not in this row here. They're separate from that. So now what I'm going to do is put in my inputs. 60 is my N. My present value is 21,000. My interest rate is 4. And I'm going to compute my payment of $386.75. Okay, $386.75. Again, it's a negative number because that's a cash outflow for me. So my payment is $386.75 per year, or excuse me, per month. So the question here says, if you need your monthly payment to be at most $320, given the above terms, what is the most you can finance today? So now I'm going to solve for my present value. My payments per year are still equal to 12. My N is still equal to 60. My present value is what I'm looking for. My future value is equal to 0. My interest rate is still 4, but my payment is negative $320. Okay, and I'm solving for the present value. So I'm going to press second and future value to clear out these variables. 60 is my N. My future value is 0. My interest rate is 4. My payment is negative, 320 negative. Try that again. There we go. My future value is 0. I'm going to compute my present value. My present value is $17,375.70. So I have to limit myself to financing this amount if I don't want my monthly payment to be more than $320. The next question says, you are trying to decide whether to purchase a home or continue renting. The home you're considering purchasing will cost $170,000. You can make a 20% down payment and you will finance the rest for 3.5% for 30 years, and you'll make monthly payments. What will be your monthly payment? So again, my payments per year equal to 12. And although I put that in my last with my last problem, I'm going to just double check that. The present value. So for this, my present value is not $170,000 because I'm making a 20% down payment. So I can find this in two ways. I can take 0.2 multiplied by 170,000, which will give me 34,000. And I can subtract that from the 170,000, or I can just multiply 170,000 by 0.8. It'll give me the same answer. So that's what I'll do here. I'm going to take 170,000 multiplied by 0.8, because this is the amount I need to finance, is 136,000. And I'm making a $34,000 down payment. And then I will finance the rest for 3.5%, so that's my interest rate per year, is 3.5, for 30 years. So my N is going to be equal to my 30 years multiplied by my number of payments per year, or 360 payments. So now I need to calculate my payment. So in my calculator, like I said, I'm going to start off by pressing second and IY, just to make sure that that is 12. If it's not, type in 12 and press enter and you'll be good there. I'm going to clear out my time value of money variables. I'm going to put in my present value at 136,000. My interest rate is 3.5. My N is 360. My future value is 0 because I'm going to pay this off in my 30 years. My payment's going to be equal to $610.70. And you might notice I'm keeping these as positive numbers. You can put a negative or a positive number, just depending on the situation. My next question here says, the home is expected to increase in value by 4% per year. If you sell the house in 7 years, how much will you get for it? So we start now with $170,000, and this is just a lump sum problem, the kind of problem we started with. So my present value is equal to, and I'm going to make this negative, 170,000. My N is equal to 7. My interest rate is equal to 4. And now I'm going to solve for my future value. Notice there is no payment because I'm just finding the future value of a lump sum. My payments per year, I need to switch this back to 1. Okay. So I'll start with that, press second, and I/Y, and then 1, and then enter. And now I'm going to put in all the rest of my variables. Press second and clear everything out here. 170,000 negative is my present value. My payment is equal to 0. 4 is my interest rate. 7 is my N. I'm going to compute my future value of $223,708.40. So that's how much my house will be worth in 7 years. So now I'm going to move to the last page of the problems. And these two problems have to do with non-constant cash flow. So we're going to be looking at a different part of the calculator now. In the first problem, we have non-constant cash flows for 5 years. There's no time zero cash flow in this case. yet. We're going to put a time zero cash flow in the second part of this question. But what we're looking for is the present value of the project. Actually, reverse that. We're not going to put a present value in this project. We will do that for the next question. So if the required rate of return for the company is 15%, what is the present value of this project? So what I'm going to put in here, I'm just going to show you where we're going to start with. I'm going to press CF. That stands for cash flow. And this opens the cash flow worksheet. You can see I've already got some numbers here and they don't match what's up here. So I need to change this. I need to clear everything out. Otherwise, I'll just be hopefully covering everything, but I may or may not get everything. So I'm going to go here and press second. And down here at the bottom, above the CE/C button, it says clear work. I press that and you can see everything's cleared out now. Okay, so I press second, clear work to change everything around there. So again, I'm going to start with my cash flow button. My cash flow at time zero is just zero. We don't have a negative cash flow to begin with. Cash flow at time one, CO1, is equal to 50,000. And then I want to press enter again because there's no equal sign up here. This next, so I press the down arrow. It says FV, FO1. So F, in this case, FO1 means the frequency of that first cash flow. This is nice to use if you have multiple years with the same cash flow. So let's say you're working on a problem like this and you've got 5 years where the cash flow is $50,000. Instead of going through and typing in $50,000 5 times, you could just put 5 here. In this instance, though, we only have one cash flow of $50,000. So I'm going to press the down arrow, just leave that alone. $80,000 is my cash flow at time 2. And then enter. And then press the down arrow, just one of those. Cash flow at time 3 is $70,000. And then enter. Cash flow at time 4 is $100,000. And then enter. Oops, that was wrong. I only put 10,000. That's going to give me the wrong answer. So let me redo that. 100,000. There we go. And then enter. And the cash flow at time 5 is $80,000. And then enter. Okay. So all my cash flows are in. I usually press the down arrow a couple times just to make sure there's nothing else out there. There isn't, so I'm good. So now I'm going to calculate the present value of this project if the required rate of return is 15%. Okay. So to do that, I'm going to go and press the NPV button. It stands for net present value. My interest rate is 15, so I'm going to put 15 in for I. And again, I'm going to press enter to get that equal sign in there. I'm going to do the down arrow here, and it says NPV is equal to, I'm going to press compute, 246, 945, and 35 cents. So 246, 945, and 35 cents. So what this number represents is the most the company can invest in this project today and still earn its 15% return. If it invests any more than that, it's not going to get its 15% return. So the question says, if the cost of the project is $300,000, should the company invest in the project? And the answer is no. Because 300,000 is greater than the value of that project today at 246, 945, and 35 cents. So the next question looks just like the previous question, except what I'm going to do here, I'm going to go ahead and calculate the present value of the project. But then I'm going to do this a second way, where I put the cost of the project today, just to show you how that's calculated. So if the required rate of return for the company is 20%, what is the present value of this project? So in my calculator, I'm going to press my CF button, press second, and CE/C. So that clears everything out again. I'm going to start off just by answering the first question. My cash flow at time 1 is $70,000. And then enter. My cash flow at time 2 is $85,000, and then enter. My cash flow at time 3 is $95,000, and then enter. My cash flow at time 4 is $110,000, and then enter. And my cash flow at time 5 is $80,000, and enter. So to start off by doing it the way that we did it last time, I'm going to press NPV. My interest rate is 20%. And so my net present value is $536.01. So the present value is equal to $257,536.01. So you should be able to look at this and tell that you shouldn't invest in this project, should not invest, because it's going to cost you $350,000. The next thing I'm going to do is now I'm going to go back to my cash flows though, and I'm going to put this in as my present value and then calculate the NPV to show you that the net present value would be negative. So I'm going to go back to my cash flows. My cash flow at time 0 now is going to be my investment, and it's a negative number because it is an investment. So it's a cash flow out of my pocket. I'm going to press enter. I'm going to go back to the NPV function. My interest rate is still 20%, but now I'm going to press compute, and we can see that the net present value, if I invest the $350,000 today, is negative $92,463.99. So the net present value, because the net is including that investment at time 0, negative $92,463.99. Earlier I mentioned, sometimes you get negative numbers here, and it's kind of the situation where you want to determine if you want to write down a negative number. In this case, the NPV is negative, and that is important to make that distinction. The last thing I'm going to do here is calculate the rate of return if we made that investment. So I'm going to go to IRR, which stands for internal rate of return. All my cash flows are already in, so I don't need to mess with that. I'm just going to press compute. And my rate of return, if I made that $350,000 investment today, would be 7.83%, which is less than my required rate of return of 20%. So my rate of return, given those cash flows, is 7.83%, which is less than my 20% requirement. So in this case, you would not want to invest. So that goes through all of the problems that I had on here. Let me know if you have any questions.